Okay, the directions here said graph and state the domain and range. First thing we do when we're taking care of graphing is any shifting. Shifting looks like adding and subtracting. So do we have any shifting in number 18? No. So that means that our first point is right in the middle. Subtract. Don't move side to side or up and down. Then we make a chart. What are good x values for square roots? 1, 4, and 9, because those are numbers we can take square roots of. What's the square root of 1? Square root of 4? Square root of 9? We plot those from our first point, which happens to be the origin this time, but even if we had shifting, we plot from that first point, not from the original origin. So 1, 1, and 4, 2. And I can't fit the last one, but that's fine. As long as you can get 3 on, you've got enough to get a good enough shape here. Be careful that your line does not go past that endpoint. A lot of people were carrying it on a little bit too far. And definitely don't put an arrow on that other end. It's an endpoint. It actually ends at that point. It does not go on any further. So then we need to consider domain and range. Where does x begin in this graph? 0. And does it get bigger or smaller from there? Bigger because it goes to the right. It's going to the right. It'll be bigger or greater than. Where does y begin? 0. Does it get bigger or smaller from there? Bigger because the graph is going upward. Number 19 doesn't really look like a square root or a cube root, but we have a 1/3 power. What is a 1/3 power? A cube root. So this is really asking us to graph the cube root of x. Is there any shifting here? No. So this graph will begin right in the center, and we'll make a chart. What values are good cube root values? Okay, numbers we can take cube roots of. What's the cube root of? -8? -2, cube root of -1. And we'll always have a nice symmetry that happens in our charts. Then we plot these again from that center point, which happens to be the origin, but if it's not, and if we've shifted, we plot from that first point. Now I can't really fit either of those ends on here, but I am still going to go out and do them because you want to have at least one of your side points there. Otherwise, your graph is likely to start looking too much like a straight line, or it's going to be way too steep. It's good to have one of those outside points at least as kind of a parameter for how tall this graph becomes. These get arrows on both ends. So then what do we think about domain and range? They are both all real numbers because the graph goes on forever in both directions, side to side and up and down. For 20, do I have any shifting? How do I shift for that 5? 5 to the right. Something that is with the x, so under the root connected with the x will go side to side and backwards of what it says. So a -5 will go over to +5. If it was x plus 3, it would go back to -3. What about if I had adding or subtracting outside of the root? What does that do? Up or down, and does what it says. Okay, so if there was a +1 outside of the root, that goes up 1. Then we make a chart, but we get to ignore the -5 because we already dealt with it. And a square root, our good square root numbers are 1, 4, and 9, which gives 1, 2, and 3. Plot from that starting point, not from the origin. So from that starting endpoint, over 1, up 1, over 4, up 2. I don't really have room for, but I'm going to go out there anyway because 3 points are good. Otherwise, students' graphs tend to start to get way too tall. Domain and range. Where does x begin? 5. Does it get bigger or smaller? Range. Where does y begin? Does it get bigger or smaller? Okay. If the graph was pointing in the downward direction, so if we had the lower half of the parabola, that would be a y is less than. Questions on graphing? That was 7.5, if you want more practice. And to finish it out, what we learned yesterday. To solve the equation, start by getting the power or the root thing alone. So what do I do first in 21? Or start by subtracting 5 to get the power or root thing alone. And then how do I get rid of a 1/2 power? Raise it to the power of 2 over 1. Because that gives me just x to the first equals 1 to the 2 over 1 is 1 squared, which is just 1. So when we have a fraction exponent, we raise it to the reciprocal power. What do I do first on 22? Divide by 4. Begin by getting the power or root thing alone. Then the 5 and the x and the 6, they're all trapped. So how do I get rid of that root? It's a square root, so we square. Whatever kind of root it is, we do that kind of power to undo it. Then what do I do to solve? Subtract 6. And divide by 5. Last one. What do I do first? Cube. Since it is a cube root, we do whatever kind of power to cancel the root. So we cube both sides since everything was trapped underneath. What is 2 cubed? 8. For some reason, with those lower cubes like 2 cubed and 3 cubed, students will often just multiply. So just be really careful and cautious that when you're doing a power, you're really doing a power and not just multiplying. 2 cubed is 2 times 2 times 2, which is 8, not 6. Then what do I do? Subtract 4. And then square root. And I get x is equal to positive and negative 2. When we take an even root, we need a plus and minus. Now we got 2 solutions, so we want to make sure that these are both good and not extraneous. So if I plug in a positive 2 to the original equation, positive 2 squared is 4, plus 4 is 8, cubed root of 8 is 2. So that works. If I plug in a negative 2, what is negative 2 squared?
4.
Still 4, plus 4 is still 8, cubed root is still 2, so they are both good solutions. Neither one of those is extraneous. But if you get more than one answer, it's a good idea to check they all work. This is what we learned yesterday in lesson 7.6 if you want more practice there.